Welcome back to P2. Today we're looking at equations and identities, unit 6.6, and this is where we bring together all the elements of the last few videos, in particular the last three. So nothing new, just about how we apply them all together. So let's get stuck into a few examples. So here you'll notice we have sine squared and a cos. And this is a very familiar form. It's almost a quadratic with a squared term, a single term, and then just a constant. But if it's a quadratic and we want to be able to solve it, we need to have these as the same trig identity. Okay, now sine squared, because it's squared, this one we can change easily. We can't change this one. So we want to change this sine into a cos. So if you think back, we had sine squared x plus cos squared x equals 1. That means that sine squared x is the same as 1 minus cos squared x. This is something that you need to know off by heart. You need to know it very well, and when you convert it into either sine squared equals or cos squared equals. So let's go ahead and substitute this in. So we get 1 minus cos squared x minus cos x minus 1 equals 0. Expand our brackets. 2 minus 2 cos squared x minus cos x minus 1 equals 0. Now, I really want this cos squared to be positive. That's how I prefer to solve these quadratics. So let's add it, so we can take it to the other side essentially. 2 cos squared x plus cos x. 2 take away 1 is 1, so it's going to be negative 1 then on the right hand side. Now at this point, hopefully you've noticed it is a quadratic. Cos squared, cos, and a constant. Now some of you will be happy just factorizing it as it is. Some of you will prefer to use a substitution. I'll show you both ways and you can go with whichever one you find easier. So our option 1 is just simply to factorize it as it stands. Now there may be times where you'd have to use the quadratic formula, but most of the time with these they are able to factorize. So we've got to have a 1 and a 1. We're going to need this one to be positive and this one to be negative. That gives me 2 cos squared x, 2 cos x, take away cos x is 1 cos x, and minus 1 times 1 is negative 1. So this means that 2 cos x minus 1 equals 0, cos x plus 1 equals 0. So this is going to give me that cos x is equal to a half, cos x is equal to negative 1. And then from here it's about finding my angles. So immediately let's look at the acute angle. So when I want to find the acute angle here, I'm going to get 60 degrees. And a quick look in my my cast diagram, 60 degrees, cos is positive, so these two sections, we're going in the positive direction, and we want to go all the way as far as 360, so it's going to be 360 minus 60, so 300 degrees, and it's just the two answers. And then for the second one, where cos x equals negative 1, this only happens in one place between 0 and 360, and it happens at 180 degrees. So my answers are x equals 60 degrees, 180 degrees, and 300 degrees. Now, back to what we were talking about earlier was the second option here. Now, I'm only going to show you part of this because once you get down to this point, the final steps are the same. So your option here would be, say, to let y equals cos x, and we're using y not x because we've already got x within here, so we wouldn't say let x equals, it would be quite silly. So this gives me 2y squared plus y minus 1 equals 0. People prefer to use this substitution like this sometimes because they just are more used to solving this style of question. So exactly the same process, and it's going to be exactly the same answer. So y equals a half, y equals minus 1, but y was just cos x, wasn't it? So cos x equals a half, cos x equals minus 1. So exactly the same little bit. The only difference is using the substitution so that you're just dealing with a single letter rather than the whole kind of trig bit, the cos or a sine or a tan and so on. Doesn't matter which way around you use it. I generally, most of the time I'll do it this way, sometimes I'll do it this way, especially if I'm going to use a quadratic formula. Sometimes I will do it this way, sometimes I won't. So, you know, maybe get used to trying both ways and just see which one you prefer. Now, nice second example here. 5 sine squared theta plus 30 equals 2 sine theta plus 30. And I just want to bring your attention to this initially. This is like, imagine you had like 5x squared equals x. Okay, what a lot of people will do is they divide by x. And then they go, oh, x equals 1/5. And they do the same kind of thing, and that's wrong, by the way, for this. They'll do the same kind of thing in this trig. But for this, if I do that, what I'm actually going to do is lose a set of answers. So imagine I divide by sine theta plus 30 there. I'd have 5 sine theta plus 30 equals 2 sine theta plus 30 equals 2/5, and I go away and solve it. But that is incorrect. Okay, what that's going to do is that's only going to give you one set of solutions. You're going to be missing a second set of solutions that are really important. So let me show you how you should be approaching it. So this type of question, what I'm going to do is I'm going to take everything to one side. So making it equal 0. Then I'm going to factorize. Maybe I should have used a more straightforward question first. Now that I've factorized, what I can say is that sine theta plus 30 equals 0, or 5 sine theta plus 30 minus 2 equals 0. So here we get sine theta plus 30 equals 2/5. So this is what we were looking at just now, a few minutes ago, but this is the set of solutions that I am missing. Okay, really, really important. Now, I can go ahead and solve from here as we did previously, but what I'm actually going to do is I'm just going to rewind a few steps because we've got here theta plus 30 and it's not very nice to use. So let's replace that, but let's replace it at the start and then that'll make our lives so much easier. So we'll say let y equals theta plus 30. And while we're at it, let's change our range as well. So a range for y is between 390 and 30 degrees. Now, I'll skip a little bit, fast forward here. And now we're in the same spot as before, but we're using y instead of that theta plus 30, which is a lot nicer to do. So sine y, when is that going to be 0? So it's going to happen when y is 0. That's not going to work for us because it's outside of our range. Then it's going to happen at y equals 180 and y equals 360, both of which are within our range. For this one, we'll get the acute angle first. So we want inverse sine of 2/5, so we get 23.6 degrees. Thinking about my cast diagram, that's my acute angle, 23.6. Sine y equals 2/5 is positive, so these two sections. And if you can see, this actual value won't be the first answer because it falls outside my range. So we've got here 180 minus it, so y is 180 minus 23.6. Second answer then will be 360 plus 23.6. And then after that, there will be no answers. So that's 156 degrees to 3 significant figures. And we've got 384 degrees to 3 significant figures. Now, these are obviously in terms of y. We want them in terms of theta. So remember that y equals 156, 180, 360, and 384. And that's the same as the theta plus 30. Now, obviously, I won't normally write these extra steps down. I'm just doing it for you guys to hopefully follow. And remember, you normally use the full answer in your calculator, but since we're only taking away 30, this is quite a straightforward one. And these are all to 3 significant figures, which is often what angles are rounded to. And of course, you can always check a few of these answers in your original equation or identity here, equation in this case. Final example. So for this one, we need to remember that tan theta can be written as sine theta over cos theta. So we get sine theta over cos theta equals cos theta. So sine theta equals cos squared theta. Cos squared can be written as 1 minus sine squared theta. So sine squared theta plus sine theta minus 1 equals 0. Now, it's quite easy to see that this one is not going to be possible to factorize. So we're going to use the quadratic formula. So you think, your values of A is 1, B is 1, and C is negative 1. Okay, so that will give me, now I'm just going to jump straight in with the answers here. And we go minus 1 plus root 5 over 2, and minus 1 minus root 5 over 2. So finding my values of theta gives me at first 38.2 degrees in this one. Now in the second one, I can see that this is actually going to be a minus value. And in fact, once I put it into the calculator, this is a value that is minus 1 point something. So it's actually outside the range of sine. So this is not possible. So we've just got one value, one set of answers to find. Now, double checking, we can see that minus 1 plus root 5 over 2 is a positive value. So when we look at a cast diagram, we are looking in these two sections here. We're going from 0 round to 180 at first. and we've got 38.2. So our second answer comes at 180 minus our 38.2, and that is 141.8 degrees. Now, if I think about the negative set of angles, it might already be obvious to some of you, but negative is going to go in this direction, so 0, minus 90, minus 180. And since these are the two quadrants that our values are going to come in, there's going to be no answers between 0 and minus 180. So we've got two answers for theta, and it's 38.2 and 142 degrees to three significant figures.